Thank you for being part of Lecture 16 from Dr. Emanuel on triple integrals. We're going to be discussing single integrals, first integrals, double integrals, triple integrals. We're going to go through the theory, spend some time on what's the order that they should be done in. Also the limits. I was told that limits are very important of how to determine the limits on integrals. Okay, so we're going to spend some time on that, just so that we can get a better feel of what's going on. Okay, so when we talk about integration and order of integration, when we talk about integration of one integration, we're just trying to find the area underneath a curve. That's all. So basically, we're just taking a dx here just to find out what this volume is. What this area is. Then, when we go to double integrals, we want to be able to take the area here, okay, where you have your dy dx, okay, and what we want to do is if we take this, I call it a split, just this little piece here, spliff, and we take this and we're going to start off here and we're just going to keep going all the way across till we get to x equals b, from 0 to b. So you're just taking this little sliver, that's what it's called, the little sliver, and you'll just be doing that all the way across. And then when you want to find out for your limits, so you're going from y1 to y2 over this area as you slide the sliver all the way across as it keeps going up and lowering all the way to b, where x is. Then the same thing, we can look at it as we take a sliver here, and then we're going to run it from y equals 0 to y equals 1, and this here will be y1 at this corner here where it begins. And this y1 will keep increasing until we reach our height, which is h. Okay, so we can find out what y1 is when we have y2 here. So we can just solve for x. So to solve for x, all we have to do is take the height over the base and take the inverse of it, and we get the base over the height times y equals x. Just that simple, okay? Please don't make these complicated. Then we want to know, what is the order of integration? Does it matter of which one we take first? In which order do we go? Okay, but if we change the order, we have to change our limits. So the limits are very important of how do we pick these limits. Okay, so here we mentioned that if we do dy first, the function of f of x, we're going from y1 to y2. So this here gives us our y1, this gives us our y2. As it goes from what? From x equals 0 to x equals b. And if we switch it around and we want to look at our x first, then we need to go from x1 to what? x2. Our x1 to our x2 as x changes. And we're going to be moving this sliver. Okay, we're going to move it from y equals 0 to y equals the height, which is h. Okay, before b went from 0 to what the length of the base is. So base times height. Okay, so now I hope we have a better feel of this dy dx as it relates to the area when we do double integration. Again, let's look at that. We're talking about our dy dx. Okay, this is going to give us our area that we're going to have. And then we're going to do a dz. It's going to be like a cylinder that goes up. Okay, so we have this dx, dy again, as we mentioned. And then this cylinder is our dz, this little cube. So we're going to take this little cube and then put another little cube here and another little cube. So we're going to start off at dz equal what? 0 all the way down here. And we're going to take dz all the way up and keep adding these cubes till we have a full column. Okay, and so that's what we're looking at. That's how we're going to control the, what do we call it? Control the limits on our integral. Okay, so here we have it again, dz, okay, where z is a function of x and y. Z1, we have z2, it goes from z1 to z2. And we have here our y1 to y2. And we have our x1 to x2. And this one, as we do inner, dz goes with this integral, dy goes with this integral, and dx goes with that integral. Okay, now that we've talked about it, let's look at an example to help solidify it in your mind. Remember, this little cube, this area here for dx, dy, and then we're just adding the dz here, and this is a cube, and we're going to add another cube and another cube all the way from z equals 0 all the way up to z equals 2. Just going to keep doing that. So we have here our dz that we do first, then we do our dy, and we have our dx, and then you can see the limits. So what are these limits? As we mentioned to you earlier, the dz is going to be going from 0 to 2. Our dy is going to be going from 0 to 2, and our dz is going to go from 0 to 3. So if we integrate dz for z, we get just of 1, that we just get z. And then since the lower limit is 0 and the upper limit is 2, so then the 0 drop out, so we'll just get 2. So now we have 2 dy. Okay, with this 2 dy, we're going to integrate this. There's no y here, so it's just going to be 2y will be the answer for our integral. And so when you take your 2y, our lower limit is going to go to 0. As this goes to 0, we have 2. We put y in here for 2. We get 2 times 2 is 4. So that's going to give us 4 dx times, integration of this term. So there's no x's in here, so it's just going to be 4x, because x is a constant. And we're going to be going from 0 to 3. We plug in 0 here, that's going to go 0 on our lower limit. Our upper limit would be 3 times 4, which will give us 12. So our volume is what? 12. Now, how else could we verify this answer? Well, if we have a cube, we know a cube is length times width times height. So if we multiply our length times our width. 3 times 2 is 6, times 2 is 12. There it is. Wonderful. This is exciting. Okay, so what we're going to do now that we have covered that, we're going to leave this up to you. They said around 10 minutes. So I think we did a good example. And so when we come back, we'll do some more examples. And we'll try to go through this so that you can understand how to find the limits. Very important to have the limits and the order of integration, that you match them up. We pray that you're getting a blessing and that you're understanding this material. Prepare for your exam tomorrow. All right, enjoy.